Question 1 from Chapter 12 is asking you to give the IUPAC name for some molecules. And so the first thing you want to do is to find the number of carbons. That's going to give you the prefix. Here we have 2 carbons, and so the prefix is F. Then, if you notice, there are only single bonds in this molecule. And so if you have all single bonds, the infix is AN, so FAN. And then for the functional group, we do have a functional group here because we see symbols for elements other than carbon and hydrogen. And so this right here is our functional group. Now, that's an OH, and an OH is an alcohol. So the suffix is OL. Now, you would normally want to give a number to say where the OH is attaching to the backbone. But in this case, whether you put the OH on the carbon on the right, or if you put it on the carbon on the left, or I should say the carbon on the left like this, these are both the same molecule. Just imagine rotating this 180 degrees, and you'll end up with the molecule on the left. So because no matter where you put the OH, you end up with the same molecule, you don't have to say where it's attached. But that's the technical rule. But if you're dealing with a professor who is a little more lenient and who's letting you include numbers all the time, you would just want to make sure that you number the carbon chain to give the OH the lowest possible number you can. And the way to number this chain to do that is right to left. And in that case, the OH would be attaching to carbon 1. So you could get the answer 1-ethanol, and a lenient professor may accept that without taking points off. But the technical name for this, if you looked in the back of a book or in the IUPAC nomenclature, would be ethanol, which is drinking alcohol. How about this one? All right, there are no branches here, and so the first thing we want to do is to find the prefix. So that depends on how many carbons we have. Here we have 4 carbons, so the prefix is bute. Next, you can see in the molecule there are all single bonds. If you have all single bonds, then the infix is AN. And we do have a functional group. You can tell because the skeletal structure has symbols for elements written in. Specifically, it has an O and an H. And those are the elements in an alcohol. An OH group coming off of a carbon chain is an alcohol. And the suffix for that is OL. So we're dealing with butanol. Now in this case, where you put the OH makes a big difference. You could have it how it is in the middle of the molecule, or you could have it on the end of the molecule. And no matter how you twist or turn or rotate the molecule on the right, you'll never get the molecule on the left. So these are different molecules, and you have to say where the OH is connected here. Now to do that, you want to number the backbone. You could imagine numbering this either left or right. I have it numbered left to right in blue. If you were to number it right to left, it would be like this, 1, 2, 3, 4. Notice that if you number it right to left, the OH is coming off of 2. That's the blue way. If you number it left to right, as in the red, it's coming off of 3. You want to give the alcohol the lower number, so you'd number it the blue way, and the alcohol would be coming off of carbon number 2. So the name for this molecule would be 2-butanol. All right, how about this one? There are no branches here, and so the first thing we're going to do is just look for a prefix. In this example, you have a total of 1, 2, 3, 4, 5 carbons. The prefix for 5 carbons is pent. There's all single bonds between these carbons. And so if you have all single bonds, the infix is AN. Last but not least, you see that you do have a functional group, elements other than carbon or hydrogen, and so that OH is an alcohol, and the suffix for that is OL, so this is pentanol. You do have to say where the OH is attaching to the backbone. To do that, you can number the backbone either left to right or right to left. If you number it left to right, then the OH is coming off of 2. If you number it right to left, the OH would be coming off of 4. You want to number it in the way that gives it the lower number. That's the blue numbering. And so this is going to be 2, always between numbers and letters goes a dash, 2-pentanol. That's the name for this molecule here. And it says to give the IUPAC name for this molecule. Now this is a special molecule. There's one molecule that should stand out. If you ever have a 6-membered ring that either has alternating single and double bonds or has a circle in the middle, either of those, that's a very special molecule called benzene. And there are a few derivatives of benzene that you should keep in mind. One of the most important is a benzene ring with an alcohol coming off of it. So this right here. Derivatives of benzene have their own names. So if you have a benzene ring with an OH coming off of it, it's called phenol. There's no way you could possibly know that except having been exposed to it and having memorized it. So a benzene ring with an OH coming off of it is phenol. We have that here. The ring has another branch, but the phenol is going to be the backbone. So I'm going to circle that phenol. That includes the OH. That's our backbone. Now with these, you always start numbering at the carbon that has the functional group on it that gives the benzene its new name. So here, the carbon that gets number 1 is the one that has the OH on it. We could number this clockwise or counterclockwise. We'll get a lower number for bromine if we do it clockwise. So the bromine is coming off of carbon number 3. And because it's bromine, you take the first syllable, it's a halogen. In group 7A, take the first syllable and add an O. And that's the name for the branch. So the name for the branch is 3-bromo. The name for the backbone is phenol. You put it all together, you have 3-bromo phenol. And that is the name for that molecule.